Okay, today we're going to be looking at the chain rule. So if we have something of the like y equals 3x minus 2 to the power 7, this we might want to differentiate. It's not going to be very easy. We could expand it out, and if you've done the binomial coefficients, you would realise that expanding anything to the power 7 is going to be long and messy and complicated. Or we can use something called the chain rule. So what we're going to do is we're going to say u is 3x minus 2. So now y equals u to the power 7. So we have two functions now which are nice and easy to differentiate. So the chain rule is, if we've got this function y, dy by dx is the same as dy by du multiplied by du by dx. So this is the chain rule. So with our example here, so if we now differentiate u, so du by dx is going to equal 3. And dy by du is going to equal 7u to the power 6. And the chain rule states that dy by dx will be dy by du multiplied by du by dx. So dy by du is 7u to the power 6, and that's going to be multiplied by 3. And now we can substitute back in for u here, and so 7 times 3 is 21. And we'll put our value for u back in, so it's 3x minus 2 to the power 6. Let's do another example. So want to find the derivative of y equals 2 over 3x squared plus 1 to the power 5. So we will take u will be, let's make u equal to 3x squared plus 1. So now y equals 2 over u to the power 5, which is the same as saying 2u to the minus 5. So now we're going to be du by dx is 3 times 2 is 6x, and dy by du is minus 5 times 2 is going to be minus 10. U to the power minus 5 minus 1 is minus 6. So dy by dx is du by dx multiplied by dy by du. So 6x times minus 10 u to the minus 6. So minus 10 times 6 is going to be minus 60x, and we're going to put our u under here. We're going to substitute back in for this, so we'll have 3x squared plus 1 raised to the power 6. And one more problem. The curve y equals ax plus b passes through point 12, 4 and has gradient of a quarter at this point. Find values for A and B. Now, the first thing we see, we've got two unknowns that we want to find. So when you have a question where you've got two unknowns that you want to find, you're thinking immediately simultaneous equations. So we're going to set up two equations which we can work with, so we can work out A and B. So let's take what we know for y. So when x equals 12, y equals A times 12 plus B, and that equals 4. So we're going to call this our equation 1. Then we are going to differentiate this. So we're going to say, using our chain rule, so using the chain rule, differentiate y. And in an exam kind of question, you would know that you were going to differentiate y because it's talking about a value for the gradient at this point, and as the derivative would give us the gradient. So we're going to say y equals square root of u, where u is ax plus b. So du by dx equals a, and dy y equals u to the half. So dy by dx is u to the minus a half, which is 1 over root u. So dy by dx equals du by dx times dy by du. So we have du by dx is a times 1 over, oh sorry, we've not taken this down, not taken the half down here. So I have a half here, that's 2. 1 over u and the 2 here. So we'll put that back in, so we will have a over 2 root ax plus b, and we know at point 12, 4, the gradient is a quarter, so a quarter must equal a over 2 a 12a, start for neatness, plus b, and we're going to call this equation 2. So I'm going to write the two equations here. So we have 4 equals the square root of 12a plus b, and we have a quarter equals a over 2 12a plus b. And solving these simultaneous equations, we get 2a equals 4, so a equals 2. Substituting that back in, we'll get b equals minus 8. So y equals the square root of 2x minus 8. So I hope that helps.